Hi guys, welcome back to yet another fun DIY boat repair video. I'll start out this video here in the workshop by doing a little bit of work and some experimenting, and then a little later in the video we're going to head down to Athena. As most of you know, over the last couple of months I've spent a bit of time working on Athena's new rudder, which is represented by these two molds and these two spiffy vacuum-infused rudder shells. With the two rudder shells done, I am getting dangerously close to being able to button up this little project. And I've also got the expanding epoxy foam that's going to go inside the rudder. Or at least what's potentially going to fill the rudder, because I have no experience working with this stuff. So I want to do a few experiments, and that's what we're going to be doing in the beginning of this video, just to figure out how this stuff is to work with, so I minimize the chance of me messing up my perfectly fine rudder shells. As far as what's going to go inside of the rudder to actually attach it to the boat, there's been a bit of back and forth in the comment section as to whether or not I should go ahead and reuse the old rudder stock. After having consulted a lot of smart people, I've decided to go ahead and reuse the old rudder stock, but with a couple of modifications and with one very important little detail. If we start with the important detail, that is that this thing is going to go for a swim in a ginormous tub of acid before it gets reused. What that's going to do is it's going to remove all of the free iron on the surface of this thing, which is basically going to reset the corrosion timer, if you will. I am in no way an expert when it comes to stainless steel, but thankfully, there are a lot of clever people in this world, and I feel like I've talked to a lot of those clever people over the last 3 or 4 weeks about this rudder stock. There are some scary terms that get thrown around when talking about stainless steel, like for instance crevice corrosion, and as you can see here, there is a little bit of corrosion or pitting here on the rudder stock. The aforementioned clever people I talked to, whether it be welders with decades worth of experience working with stainless steel or people of the more book-smart variety, all recommend that I go ahead and reuse this old rudder stock, saying that this is perfectly serviceable. What's apparently going to be the weak spot in this thing is where this plate is welded onto the rudder stock, as is shown right here. My good buddy Mr. Cement Boat Guy welded some trusses onto the rudder stock. He's got years and years of experience welding stainless steel, and I am but a novice, so I felt that it was better to let him take care of that. The reason we did that is this simulation here. Over here is the old version of the rudder stock without any of those little trusses on there. And as you can see, there's a fair bit of stress being placed on the weld that joins the rudder stock and the plate. Meanwhile, over here, with a truss in place, there's nowhere near the same amount of stress. The rudder is 30 years old and has survived a circumnavigation, so clearly that modification wasn't needed from the beginning, but now that I've got access, I figured it was a good idea to go ahead and beef it up a little bit. Besides adding these doohickeys and beefing up some of the welds, I've also drilled 15 holes in the plates. The thought being that these holes would allow the expanding foam on each side of the plate to sort of connect together, but I have no idea if that's going to make any kind of a real-world difference. Earlier this week, I went over the rudder stock and cleaned it thoroughly. Then I took some 80 grit paper on an angle grinder to it and cleaned up the surface. But there are some little nooks and crannies here I couldn't get into. As you can see here in this corner, the surface of the metal is a much darker color. I don't know what that coating is. It might be some kind of leftover resin from when they built the rudder, but no matter what it is, I would like to get that removed so that the giant tub of acid can do its job. This thing should now be ready for its acid swimming lesson. As soon as I get it back, I can go ahead and get it put into the rudder shells and get the rudder finished. As you can see, the Dodger is still sitting here in the workshop very much unpainted. That is because of Easter, but also because of the hunt for perfection and stupid frickin' pinholes. I thought I was ready to drop this thing off right before Easter, but then I noticed something. Yep. Pinholes, the bane of my existence. And I know exactly what went wrong here, because I didn't get all of the air out of the fairing compound. So, of course, this is 100% my own fault. That doesn't make it any less annoying, though. I've made a deal with myself. I'm gonna apply one last lick of fairing compound to this thing. And tomorrow, after I've sanded this, come hell or high water, even if there's the freaking inverse of Mount Everest in the surface of this, I don't care anymore. I've had enough. This thing is going to the paint shop. There's a saying something along the lines of perfection is the enemy of something something, and that is definitely true. And it is no fun to keep fairing and sanding forever, but the pain of fairing and sanding is temporary. A spiffy dodger is forever. And that's what makes it so difficult to leave well enough alone. Like I mentioned a little earlier in this video, I want to do some tests with this foaming epoxy system before I actually try and put the rudder together. There are a couple of things I would like to test. I've got a couple of small containers here. This one is going to test how well the foaming epoxy flows through a narrow opening, how well it expands on the other side of that narrow opening, and also how well the foaming epoxy adheres to a laminate surface. And then this one here is going to give me an idea of the pressure the foaming epoxy exerts as it's expanding. Why do those tests? Well, I think ideally I want to join the two rudder halves together and then pour in the foam. But I don't know how much pressure that foam is going to exert, and I don't want the rudder to bulge because of that pressure. Now, ideally, I think I want to raise the rudder upright and then pour it that way, because that would have the foam flow past that big solid plate in the rudder stock more easily. But if I do that, then I'm going to have a lot of epoxy trapped in a small area. And just like with West Systems 105, that is going to generate an insane amount of heat. And I don't think I want that. So I want to see if I can lay the rudder flat on its side and then simply just have the foam press up through those little holes I drilled in the plate on the rudder stock. Before I set up these little experiments, I want to give a quick shout out to another YouTube channel, and that is Just About Sailing. Paul has already made a rudder using this foam, and he's got some pretty cool videos about that and other boat DIY stuff. So if you're into that, head over and check out Paul's channel. I'll include a link down in the description and also pop out one of those newfangled YouTube cards. According to the documentation, this stuff should expand about 4 times at 20 degrees Celsius, which is what we have here in the workshop right now. Using a bit of math, I've calculated that I should use roughly 104 grams for the small container and 188 grams for the big container. The documentation mentions that you should add 10% for waste on top of that. I've done that for the small container here because I want to test the pressure. In the big one here, I just want to see how it flows, so those extra 10% shouldn't really matter. The idea for this test is that I'll shove this piece of laminate, which is from the rudder shell that failed in the vacuum infusion, still pretty freaking spiffy. I'm going to shove this in here, and I'm going to pour the foaming epoxy in here, put a lid on it, and just let it sit like that. For the smaller test, it is just a matter of pouring the expanding foam in there and then slapping a lid on it, and that's it. Once I've mixed the two parts, I only have about 4 minutes worth of mixing time, so I'm going to have to be a little bit quick. And then 108 grams of the hardener. I've measured out the two parts and I've zeroed out the scale with an empty cup here. So now it's just a matter of getting the two parts mixed and measuring out each of these quantities for the two little tests. Of course, you guys can't see what's going on inside of these containers, which is not very satisfying. So I've set up these two cups for a time lapse. Wow, that has to be the most boring time lapse I have ever recorded. What you just saw covered an hour. This stuff is very undramatic in small quantities. What is pretty cool is the fact that this stuff is still pretty soft and squishy, and that's what I saw on Paul's videos, and that's why I think I might be able to get away with letting this stuff push up through those little holes in the plate on the rudder stock. As you can see, this is still very fluffy and kind of runny. If we take a quick peek at these two tests, on this one I can see a tiny bit of that foaming epoxy coming out the hole I drilled in the top of this lid. Meanwhile, for this one over here, if I take a light and shine it behind the container, you might be able to see that it's pushed past that little laminate barrier. It's all the way up to here. Those two tests are coming along really well. I am very optimistic. I'm gonna let them sit overnight, and then tomorrow morning I'm gonna pop them in my little epoxy heating box and let them post-cure for 6 hours at 40 degrees Celsius. This morning when I got to the workshop, the foaming epoxy had roughly the same consistency as last night. Now let's see what it looks like after 8 hours in the heating box. Wow, this is rock solid. I lined the box with a plastic bag because I didn't know if the foaming epoxy was going to expand anymore, and I'm glad I did because there was a little bit of expansion here. It's pretty cool. You can see all of the tiny bubbles in there. I have absolutely no idea how easy it's going to be to get the foam out of here, but let's give it a go. So it looks like the foaming epoxy flowed around the piece of laminate pretty easily, but having said that, there is a big void up here. I pulled the foam out of the smaller experiment, and looking at these two, I think it's safe to say that this stuff does not exert a lot of pressure when it's expanding. I mean, the top here is barely even bulging. I've cut the top off the larger of the two experiments, and this looks amazing. The texture of the foam is very uniform. There are no voids inside of this, and there are no hard spots, at least that I can see. So yeah, I am super impressed with this stuff. I've cut a thinner little sample here. Now one side of this laminate had peel ply on it, so that had a surface that was fully prepped for adhering to, and I expect the foam to have a good bond to that. Now the other side of the laminate I did not sand, so that's probably not that strong of a bond. As you can see by this shiny surface here, this is the unprepped side of the laminate, but look at all the foam that's still stuck to it. Pretty cool. It definitely seems like that foam has a very strong bond to the laminate. So far, I am thoroughly impressed with this stuff, and I think it'll make for an awesome core material for the rudder. So all that's left to do now is to figure out how to actually get it into the rudder. You guys heard me voice some of my thoughts a little earlier in the video, but if you guys have any suggestions, go ahead and leave a comment down below. As far as the core material in the old rudder, I still have no idea what this stuff is. It's definitely not sand. That would make this part ridiculously heavy, and it's actually pretty light. Now the stuff that's in here is a little bit harder than this new foam core. The foam core I am able to damage with a screwdriver. As far as this stuff, well, I can sort of get in there, but it is harder. Meanwhile, here aboard the good ship Athena, there is some good news and a little bit of bad news. The good news is that I've picked up all of the epoxy and fiberglass I need for this summer's projects. I'm gonna leave the fiberglass up at the workshop because it's gonna be much easier for me to make some templates of the pieces I need here aboard the boat and then cut all of the glass up there. Now for the bad news, which I guess is not really bad news, it's just a little bit annoying. It turns out the yard has to move Athena around a little bit over the next 2 weeks, and I don't want to cut away the remnants of the old cabin solder before they're done doing that. So I will have to hold off a couple of weeks until I start laying up glass on top of the structural members. The reason that is a little bit annoying is of course because I'm only a few hours away from actually being ready to lay up glass over here, and I would love to have all of the glass work finished here in the entire saloon by the time Ava shows up in 4 weeks. But if I'm gonna lose 2 weeks out of those 4, there is no chance I'm gonna be done. The good thing about a somewhat extensive refit like the one I'm doing here aboard Athena is the fact that there's something else you can work on. So provided I get the rudder stock back from passivation, I can go ahead and get the rudder finished, and maybe the Dodger will come back from the paint shop and we can get that mounted. So yeah, we'll see what the next 2 weeks are gonna entail. But also there's gonna be a bunch of glass to cut, so that would be nice to get out of the way. Today is a really nice cool day, and that helps a lot with the itchiness from sanding fiberglass. So why not take advantage of that, especially seeing as I've picked up some more belts for my little Makita sander here. So yeah, let's get started. What a marvelous way to spend a day. There are still the little inside corners here that I can't really get into, so I'll have to borrow Mr. Cement Boat Guy's die grinder again and maybe find some kind of different attachment for that. Then it'll only take a few minutes. So all that's left to do now is just to cross my fingers that maybe I can get Athena moved somewhere so that I won't have to wait 2 weeks until I can start laying up glass. Speaking of glass, here is that glass. This is 50 kilograms of 600 gram BX. Last weekend I made this little test here of some laminate to see how that conformed to the shape of the structural members. Since then I've had a chat with the good folks at HF Marine, and there's been a slight modification to the laminating scheme. In this, I've got 3 different types of fiberglass. 2 of those are going to be a little bit difficult to get to conform to this shape. So the guys at HF Marine recommended something a little bit different. I'm going to build up the thickness I need using BX, which is a lot easier to get to conform to all of these curves. And then apparently on top of something like this, it is very common to add a strip of UD just right here on the top. This right here is that UD. It's got almost all of the fibers running along the 0 axis here, and this is 1,000 grams instead of the 600 gram BX. As you can see here, this is pretty thick, but it's not going to have to conform to a lot of shapes, and it's also pretty loose, so this should be nice and easy to work with. Working with this 600 gram BX, I'm going to get just shy of 1 millimeter of laminate for each layer of this stuff I put down. So I'm going to put down 4 or 5 layers of this stuff, and I'm also going to have 3 layers of the 1,000 gram UD in there. That means the laminate here on the sides is going to be 4 or 5 millimeters thick, and here on the top it's going to be 8 or 9 millimeters thick. The guys at HF Marine weren't concerned about having fibers along this axis here on the side of the structural members, saying that the top was the important bit, and yeah, I guess that makes sense. You learn something new every day. I apologize if the audio quality for the last 2 minutes was a little subpar. Turns out there was a loose connection in my lavalier setup, so sorry about that. I'm going to spend the rest of the day working on the second rudder shell, doing the prep on that. But you guys have already seen me do that once on the first half, so I don't want to bore you with that. But before ending this video, I want to show you guys a little footage from this experiment. This is polyurethane foam, also known as PU. You mix these 2 parts, you stir it around, and then after 40 seconds it starts expanding like crazy, and then after a couple of minutes you've got this foam. The footage I'm about to show you is in no way sped up. This is real time, about 40 seconds after we got done mixing the 2 parts. And as you can see, this stuff expands a lot faster than the foaming epoxy. It's almost kind of a violent reaction. For the fun of it, I mixed up a couple of drops of PU foam and put it in between 2 plastic cups and put a 2.5 pound block of weight on top of it. And as you can see, that little bit of foam lifted this weight. About 4 or 5 minutes after this sample had stopped expanding, we took a foam to it, cut it in half, and measured the temperature inside of it. And it turns out this thing was over 100 degrees Celsius inside. Mind you, this was a pretty small quantity of PU. I mean, this stuff gets insanely hot when it kicks off. Why am I showing you guys this? Well, because you saw the expanding epoxy foam a little earlier in the video, and I thought it might be fun to see what PU looks like in comparison to that. And these 2 foams are vastly different in density, so you can't really compare them that way. But you saw the slow reaction of this stuff and how it exerted almost no pressure when it expanded versus this stuff that gets insanely hot and exerts a fair bit of pressure. The main reason Cement Boat Guy and I mixed up this batch of PU was because we got to talking about using this stuff potentially as insulation in fridges and freezers aboard boats. The jury is still very much out on that, but there's no doubt which one of these 2 materials I feel the most comfortable about filling my new rudder with. It is definitely the epoxy foam. And on that note, I better get busy prepping this second rudder shell. As far as next weekend, I have no idea what's going to happen. Now, if I get Athena moved, then we can start laying up glass. If that doesn't happen, maybe I'll have the rudder stuck back and we can put the rudder together. That would be fun. If that doesn't happen, well, then maybe I'll have the Dodger back from the paint shop. If that doesn't happen, well, then it's probably just going to be 20 minutes of me twiddling my thumbs, but I hope it doesn't come to that. And yeah, that is going to be it for this video. As always, feel free to leave a comment down below, and don't forget, if you've enjoyed this video, remember to leave a like. See you!